So good morning students. Today I'll discuss number system, that is the same topic that I have given yesterday. So in here we'll discuss about the number based conversion, decimal to binary conversion, and binary to decimal conversion. So first we'll see the number based conversion. So if you see the table below, it shows decimal number converting to its equivalent binary number. So here decimal number is actually an integer number. This is your normal whole numbers, which is the universally uh, accepted numbers which we users use. So like 0, 1, 2, 3, 4, like that. Okay, and based on this decimal number system, that is the integer numbers, here it is called as decimal. So based on this decimal number system, all the other number systems, that is binary, octal, hexadecimals, are formed. Okay, so here binary numbers, you pronounce it as example like 1010. You do not pronounce it like 1010. Okay, each digit is pronounced uh, one by one. So so in binary, since there is only two digits, that is 0 and 1, so based on that all the other numbers are formed. So if you see here in this 0, decimal number 0 in binary is also 0, decimal number 1 in binary is also 1, decimal number 2, that is the integer number 2, in binary it is 10. Okay, or in decimal number 15 in binary it's 1111. So these binary numbers are not generated randomly, but these binary numbers are generated through decimal to binary conversion, which we'll see in the next page. Okay, so after studying how you convert from decimal to binary, okay, come back to this table and try executing, changing all of this decimal to binary and check out whether it matches or not. Okay, so let's move on to the next page. Now in the first case, decimal integer number to binary conversion. So decimal numbers, it can be converted to binary system by remainder method or repeated division by 2 method. So in repeated division by 2 method, you divide the number of the decimal system. That means you divide the decimal number. Here in this particular example I've given here 81. So 81 is an integer number, which is a decimal number. You divide that by the radix or base 2. Once we get the quotient and the remainder, here the quotient is 40, and the remainder is when you divide 81 by 2, you get the quotient as 40 and you get remainder 1. So the remainder you can get only in two format, that is either 0 or 1. So whatever remainder you get, you write it on the, you store it on the right hand side, or you write it on the right hand side as I've written, okay, vertically, line by line, like that, from the top to the bottom. So after that we again divide the quotient by the uh, radix 2, and after that we get another quotient, and then we get the remainder, and then so here 40 is divided by 2, so that we get the quotient 20, 2 to 4 to 0, like that, right? So we get the remainder as 0. So that remainder 0 is stored on the right hand side. So this process will keep on continuing till the quotient becomes less than 2, that is 1 or 0. Okay, so if you see that particular example, we are converting the decimal number to the binary number. So by division method, we always divide by 2. Even when we're converting from decimal to binary, because binary has only 2 digits, and even in binary to decimal, we use the base 2 for the conversion. So here the results is the top digit, the top binary digit is the least significant digit, and the bottom uh, digit is the most significant digit. I've already discussed what is LSD and MSD in the previous video, that is in the first video. You can have a look at that video, okay, for more understanding. So When we produce the result for the from decimal to binary 81, okay, then for the binary we write the numbers from the bottom to the top, that is from the most significant digit which carries the maximum value to the top. So the answer will be 1010001. Okay, so this is how we convert positive integer number to binary. Okay, next we have converting decimal fraction to binary. So that is when you have the decimal point numbers. So the following rules are applied. You multiply the decimal fraction repeatedly by 2. After that, you write the integer value obtained on the leftmost of the decimal. The value will be either 0 or 1. So in this particular example, you have a decimal fraction value that is 0.625. You have to convert it into binary. So what you do is that 0.625 you multiply by 2. You get the value 1.250. So after so the integer number 1 that is on the leftmost side after the decimal, okay, before the decimal, that is stored, or that is stored, and then the fractional value that is 0.250, okay, it is carried over and again multiplied by 2. So here also you on the leftmost side you will get the value either 0 or 1 only. Okay, so again 0.250 is multiplied by 2, and then you produce the result 0.500. So on the leftmost side before the decimal, the integer value 0 is stored, and again 0.500 is again multiplied by, is carried over and multiplied by 2. So this process is keep on repeating till the fractional number becomes 0, that is after the decimal point when the value becomes 0. Okay, so here after multiplying 0.500 by 2, on the left side you get the integer value 1, but you see that after the decimal point you have 3 zeros. So now the number has changed from 0.625 to 0.00. Okay, so there you stop the process. Okay, when the number reaches 0, then you stop the process. So the result is 0.625 is equals to 0.101. Okay, so that is the binary equivalent for that particular decimal number. Okay, next we have binary to decimal. So we are converting the binary number to decimal. So to change from binary to decimal, we multiply the corresponding number with again base 2, since binary has only 2 digits. Okay, so the power of the weights from the right to the left position is power 0 for the unitary position, for the unit place, power 1 for the tens place, power 2 for the hundreds place, and so on. Okay, so here we have to convert this binary number 110010 to decimal number. Okay, so if you see from the right hand side, that is 0 into 2 to the power 0. So this the weight, okay, the power of the weight, it depends upon the bit position. So the bit position on the right hand side 0, okay, is 0 position, and the bit position 1 is number 1 position. Then again the bit position 0 is number 2 position, and bit position 0 is 3, bit position 1 is 4, and bit position 1 is 5. Since we have 2 digits in the binary, so single 2 digits in the binary, so that's why dot is included, and from there it starts 0 1 2 3 4 5. So you will see that the weight of the power, the last in the leftmost digit for the binary, is always 1 less than the binary number. So here you have the binary number 6 digits, but the weightage uh, is 5. Okay, so you can see that it is multiplied 1 into 2 to the power 5 plus 1 into 2 to the power 4 plus 0 into 2 to the power 3, like that. So if in the next line you can see that anything multiplied by 0 becomes 0. So when you multiply 1 into 2 to the power 5, 2 to the power 5 is equal to 32. So 1 into 32 is equal to 32. Okay, so again 1 into 2 to the power 4 is 16, and 1 into 2 to the power 0 or 2 to the power 1 is 2, which means 2 to the power 1 is 2. So 1 into 2 is 2. Okay, now if suppose the last digit was 1 into 2 to the power 0, 2 to the power 0 is equal to 1. Okay, in that case it will be plus 1. So you get the value 50. So the binary number 110010, its decimal equivalent is 50. Okay, next we have binary fraction to decimal fraction. So to change the binary fraction to decimal fraction, we multiply the binary digit, each of the binary digits by 2. Again, same like we did in the binary to decimal conversion, like that. Okay, but according to its weighted position. So here to convert this fractional binary number, okay, first we multiply the integer part, that is 110, by positive weightage power. So that is 1 into 2 to the power 2 plus 1 into 2 to the power 1 plus 0 into 2 to the power 0. Okay, so we get the value 6. So the binary equivalent of 110 is 6, which is actually, if you go to the first table, the number base conversion, okay, you see that you can see that here 6 is equivalent to 110, so which is correct. So likewise, okay, you can also check out the rest of the decimal numbers to binary conversion and verify whether all of these are correct or not. Okay, so moving back to our present, yeah. So for the fractional part, again we do it in two steps. First, always the integer part, and the next the fractional part. Okay, so in the fractional part, after the decimal, okay, the power is in negative position, so we multiply it by 1 into 2 to the power minus 1. Okay, so not by 1 into 2 to the power 0, but by 1 into 2 to the power minus 1, and then again 0 into 2 to the power minus 2, uh, then 0 into 2 to the power minus 3. So when you multiply that, you get the value 0.5625. Okay, so this requires a little bit of maths. So the outcome of that is you add up those two values, and then you get 6.5625. So likewise, you can try out different binary conversions to decimal fraction conversions, or from decimal fraction to binary fraction conversions, like that. Okay, so you have lots of uh, conversions like that. Okay, later on you will also see binary to octal, decimal to octal, binary to hexadecimal, decimal to hexadecimal. All those things we'll discuss in the next video. Okay, so that will be all for today.